Diagonal of a matrix. Hello everyone. Today, we are going to explore the concept of the diagonal of a matrix. Now, before we dive into the specifics of what a diagonal is, there is a very important prerequisite you must keep in mind. The property of having a diagonal is exclusively associated with square matrices. To ensure we are all on the same page, let's recall what that means. A square matrix is simply a matrix where the number of rows is exactly equal to the number of columns. In mathematical terms, we refer to this as a matrix of order n by n. Once we have this foundation clear, we will be able to identify exactly which elements within these square matrices form the diagonal. Understanding the concept. In a square matrix, the diagonal, which is more formally known as the principal diagonal or the main diagonal, consists of the elements that run in a straight line from the top left corner down to the bottom right corner. To describe this mathematically, if we have a square matrix A composed of elements a sub ij of order n, the diagonal elements are specifically those where the row index is equal to the column index. This means we are looking for the elements a sub 1 1, a sub 2 2, a sub 3 3, and so on, continuing all the way until we reach a sub nn. In practical terms, to identify these elements, you simply need to look for the entries where the row number and the column number are exactly the same. Now that we have established that this concept applies exclusively to square matrices, let's dive into what the diagonal actually is. Once you are comfortable with this definition, we will move on to a step-by-step process to help you locate these elements accurately in any given matrix. Step-by-step identification process. Now that we have established the theoretical concept of the main diagonal, let us walk through the practical, step-by-step process to identify these elements in any given matrix. First, you must verify the order of the matrix. As we emphasized at the start of this lesson, the diagonal is a property exclusive to square matrices, so you must ensure that the number of rows is exactly equal to the number of columns. Once you have confirmed the matrix is square, begin by locating the first element. Start at the top left corner, which is the intersection of the first row and the first column. In mathematical notation, we refer to this element as a sub 1 1. Next, move diagonally by taking one step down and one step to the right. This will lead you to the element in the second row and second column, which is known as a sub 2 2. Continue to repeat this process, moving one row down and one column across, until you eventually reach the very last element in the bottom right corner. This final element is denoted as a sub nn, where n represents the total number of rows or columns. Finally, list these specific elements together. This collection of values, starting from the top left and ending at the bottom right, forms the diagonal of the matrix. In the next slide, we will apply these steps to a concrete example to see exactly how this works in practice. Illustrative example. Now that we have discussed the theoretical definition and the step-by-step process, let us apply those concepts to a practical example. Please look at matrix A on the slide. This is a 3 by 3 square matrix, meaning it has 3 rows and 3 columns. Following the identification process we just learned, let us begin with step 1. We need to locate the element at position a 1 1. By looking at the intersection of the first row and the first column, we can see that the value is 5. Next, we move to step 2 to identify the element at position a 2 2. As we move one step down and one step to the right, we find that the element in the second row and second column is 8. Finally, in step 3, we identify the element at position a 3 3. This is the final element of our diagonal, located in the third row and third column, which is 6. In conclusion, by following these steps and selecting only the elements where the row and column indices are identical, we find that the diagonal elements of matrix are 5, 8, and 6. This exercise demonstrates exactly how the principal diagonal runs from the top left to the bottom right of a square matrix. Real-world analogy. Imagine you are looking at a square chessboard, or perhaps a square grid of tiles on a floor. If you were to start at the very first tile in the top left corner and walk in a perfectly straight line directly toward the bottom right corner, the specific tiles you step on along that path represent the diagonal of that square grid. In the context of mathematics, the values stored in those specific positions, or tiles, are exactly what we refer to as the diagonal elements of the matrix. Now that we have walked through a practical numerical example, let us use a real-world analogy to make this concept more intuitive and easier to visualize. By keeping this visual image in mind, you can easily identify the principal diagonal in any square matrix, which will be very helpful as we move on to discuss some common mistakes to avoid in the next slide. Common mistakes to avoid. First, be careful not to apply this concept to non-square matrices. A frequent error is attempting to find the diagonal of a rectangular matrix. For instance, a matrix with 2 rows and 3 columns. As we emphasized at the very beginning of this lesson, the concept of a principal diagonal is strictly applicable only to square matrices. Second, pay close attention to the direction of the diagonal. It is common for beginners to confuse the main diagonal with the antidiagonal, which is the path running from the top right corner to the bottom left corner. To avoid this, always remember that the principal diagonal must start at element a1, 1 in the top left corner and end at element a n in the bottom right corner. Finally, be mindful of indexing errors. When identifying elements, always ensure that the row index is exactly equal to the column index. For example, element a1, 2 is not a diagonal element because the row index, which is 1, is not equal to the column index, which is 2. Now that we have walked through the identification process and seen a practical example, let us discuss some common pitfalls to ensure you avoid these mistakes during your practice and exams. By keeping these 3 points in mind, you will be able to identify the diagonal of any matrix with confidence. Now, let us move to the final slide to summarize our key takeaways. Key takeaways. First, as we established at the very beginning of our session, the diagonal of a matrix is only defined for square matrices. Remember, this means the number of rows must equal the number of columns. Secondly, the diagonal elements are specifically those where the row index is equal to the column index, which we express mathematically as I equals j. This leads us to the sequence of these elements, which we denote as a sub 1, 1, a sub 2, 2, and so on, continuing until we reach the final element, a sub nn. Finally, to avoid the common pitfalls we just discussed, always keep in mind that the principal diagonal runs strictly from the top left corner down to the bottom right corner. To wrap up our lesson, let's review the key takeaways to ensure you have a solid grasp of the concept. If you keep these 4 points in mind, you will be able to identify the diagonal of any square matrix accurately.